Okay, if this was Hollywood, this would be about take 102, I believe. We're going to start 9-4 and 9-5, the combined lesson, again, for about the 102nd time. And you'll see I've done a little bit of tweaking so that the information, we can find the connections a little bit easier. So I'm going to start with example 1 from 9-4, but I'm not going to start with the introduction first. So the first thing we're going to look at on 9-4 is we're going to go back and we're going to just take this apart a little. They ask you to solve this problem algebraically. So to do that, we're going to go ahead and we're going to say 1/2 x squared equals 8. I don't want to know 1/2 of x, so to get rid of that, I'm going to multiply both sides by 2. That leaves me with x squared equals 16. I don't want to know what x squared is, so now I can square root both sides, ending up with the square root of x squared is x, the square root of 16 is 4, and because that could be a positive or a negative. Now, why do we need to know that information? Because that information will come in handy for when we're graphing. Now, when we're graphing linear equations, that would be the point on the x-axis. Because we are graphing a hyperbola will cross the x-axis possibly in 2 points, and in this case it will cross the x-axis at the 0, positive 4. It will also, 4, 0, because it's the x point, and it will also cross it at negative 4, 0. So those are our x-intercepts there. Now, the next thing it says is represent these solutions using a graph. So we need to go back to our original statement of 1/2 x squared equals 8, and we need to write that in standard form. So to write that in that form, we need to have it in the ax squared plus bx plus c equals 0 form. Right? I do have my term of my x squared term. This particular equation does not have a bx term, but it has a constant. However, my constant is in the wrong place. If I want it to equal 0, I need to do another step first. So to get it to equal 0, I need to subtract 8 from both sides. When I do that, now I get it equaling 0 as my form says, and I get the 1/2 x squared minus 8. So I will finish my equation here again, 1/2 x squared minus 8 equals 0. Now I have it in the correct form, and I can write it in that was in the related function form, and I can go ahead and I can find my equation then. So y equals 1/2 x squared minus 8, and to do that, and then I also know that my x-intercepts are going to be at 4 and negative 4. This equation, if you remember, we've done this in this chapter, this equation is then telling me, oh, we're still off calibration. This equation is telling me where my y-intercept will be. Okay, this looks like y equals mx plus b. So my y-intercept here is going to be at 0, negative 8. All right, and then I have to make sure, let's see if we're going to even be able to see our graph here. If I bring the sketch of the graph over now, let me get rid of some of the work so that now we can see that, because you can go ahead and review that with the recording. So I'm going to quickly get rid of this part here. I'll delete that. How do I want to do it on here? I'm going to, oh, I lost it on the screen there. I'm going to move over to my computer. Sorry about that delay. We'll go ahead and delete that, and we'll bring over our graph. And let me just do this. This would have been easier. Let me just bring that to the front. And now it'll just get rid of all that stuff behind it. So as we look at our graph here, we can see our hyperbola. We know that our x is at negative 4 and at 4, 0. There are our points there. we found out when we put it into function form that we had a y-intercept of -8, so I could sketch in my hyperbola because I know the vertex and I now know both of the x-intercepts. Now, moving on to how solving the quadratic equation can be done by graphing, or at least an estimation of it. So, I'll leave this up. You can go ahead and you can pause this at this point, but you might want to just instead come back and look at this when you, after you have put some of this with some actual exercises. So, things to notice is first you're going to write the equation in the ax squared plus bx plus c equals 0. You're also going to write it in the related function y equals ax squared plus bx plus c. That way you will find out the x-intercepts and the y-intercepts as we just did on the last screen. So moving on, let's go ahead and try example 2. This one says that we're going to solve this equation graphically. So our first step with that one is we're going to write the equation in standard form, standard function form. Sorry. All right, so when I am doing that, I need to make sure that I get my 2 here to be as my constant term, and it's going to equal 0. So changing that, I will get x squared minus x, same as here, but this time I need it to be minus 2 equals 0. I needed to subtract 2 from both sides. That's where I got x. Okay, now it can tell me, I can go ahead and I can write the related function form. Write the related function form. So if I write it in the related function of y equals ax squared plus bx plus c, it's going to look very, very similar here. We're going to have that, and I'm going to change colors here. We're going to have y equals x squared minus x minus 2. Okay, so you don't see anything that's different there. Now, the reason that I'm going to do that is, it says now I need to sketch the graph of the function. So if I sketch the graph, oh, sorry, it doesn't say that on your screen yet. Whoops, that's going to give you the answer, so I'm going to wait. Well, let's pull that up, and I'll just explain it as we go. If I'm going to sketch the graph of that function, I know from the graph that the x-intercepts appear to be at -1 and at 2. Now, how can I see if that is correct? That's the same thing I did on the first example, and we would go ahead and have to solve for x there. Then the next one would be that it would be asking me if the y-intercept is at the right place. So if we look at the y-intercept, the problem we have here is that now we have two variable terms. So if we look at the graph, we need to check that algebraically. So it's telling me that my x's should be these values, and my y should be where the y-intercept is, which is right here. So if you can't see those very clearly, then I will go ahead and I'll write these in. So we have our -1 for this x, and over here we have 2. So how am I going to check that? I'm going to go back up to check it. I'm going to put my values in here. So -1 squared minus 1 minus 2. Does that in fact equal 0? That's how I'm going to check it with my substitution. -1 squared, -1 times -1 is 1. Minus 1 is going to be 0. Okay? And then we're going to go, oh, I'm sorry, I substituted it into the wrong one, I believe. I have to go back and do it into my original one. Sorry, with all this technical difficulties we've had, I lost my place on that one. Didn't notice it till that part. All right, so let's go back to that. I'm sorry. We need to go up and substitute it instead of there. Substitute into the original equation. So as I go to -1 squared minus, and we're going to say again -1, so minus a -1, and that is supposed to equal 2. So a negative 1 squared is 1, minus a negative 1 is 1, and so yes, that does work. Now let's go ahead and try our other point, 2, 0. So I would have 2 squared minus 2, and does that equal 2 from our original equation? So 2 squared is 4, minus 2, and yes, that also works. So in this one, it says solving an equation graphically. We're going to check the check our solution on the graph and see if that is in fact a true solution. I'm going to jump up to 9.5. The last example in your book for 9.4 is using the graphic calculator. You can play around with that a little bit with the decimals if you'd like to. And we're going to move ahead here onto the quadratic formula. So on 9.5, we are going to start using the formula to solve. Now, here's the formula. And Ms. Hurley was so kind to go ahead and lend her voice to a way you can remember the formula with the Yankee Doodle song. So I'll go ahead and play that for you first, and it might be a way for you to remember it, or you'll just copy it on your paper. And I'll do it one more time for you. Maybe. So that's one little reminder that you can use possibly to help you with that formula. Now, let's put it into action, possibly. There we go. I'm using the quadratic formula. So you can see, instead of having me sing you your Yankee Doodle each time, I've gone ahead and I've put that up here in my not very well calibrated again board here. So this time it says we're going to solve or check these solutions in the original equation. So for example 1, and I think we possibly are missing a screen stuff. So let me see. There's some of those bizarre things that are going on. No, that's example 2. So I think we probably have to do this before we can solve it. So let me put in another screen. Okay. So example 1 is asking us to use the quadratic formula. So we are going to solve x squared plus 9x plus 14 equals 0. Okay, we're going to use our quadratic formula so that we can solve this one, solve this equation. So the first step is always to identify our a, b, and c. And as you can see in this one, we have already put it in it's already appearing in our correct form. So we have an a term, we have a b term, and we have a c term. Now the only thing is, remember your a term is actually an implied 1 there. So now you can sing your Yankee Doodle song here. We're going to do, here's our quadratic formula that we will use to substitute things in. So you can be singing in your own head here, following Ms. Curley's example. So there's your square root, and then your denominator is 2a. So let's use that now, and we'll substitute in those terms. So our negative b would be negative 9, plus or minus the square root. Our b squared would be 9 squared, and we're going to subtract 4. A is 1. You don't need to put that in there, but I'll go ahead and just so that you see I'm applying the formula. Times 14, which was our c term. All of that is going to be over 2, and again, I'll put that 1 in there just so you can see it's matching the quadratic formula. Now I would go ahead and I would multiply that out. Hopefully I can fit all this in here. We would have our 81 to go and write this just off to the side here. This turns out being, I'm running out of room. This would turn out being, this is also equal to 9, or it's a negative 9, plus or minus, and then when you do 81 minus 56, you're going to get the square root of 25, and that is all over 2. The square root of 25 is 5, so we have negative 9, and plus or minus 5, and that is all over 2. So our answers could be that if we did negative 9 plus 5 over 2, we would get negative 4 over 2, which would be negative 2. Or our other answer could be negative 5 minus 5 over 2, which would be negative 14 over 2, which would be our negative 7. So our x terms are going to either equal negative 2 or negative 7. And if you remember, that means that's where our hyperbola is going to cross the x-axis. I'm going to copy that real quick and see if I can paste that on our next page so that we can see on that page I have the checking there. So we're going to go and we're going to put our negative 2 and our negative 7 in there. You can see that they did that, and we should end up at 0 equals 0. Now they're putting those back into, remember I slipped up a little there on the one. You need to, when you're checking a solution, put it back into the original equation. Moving on then to example 2. Example 2 gives us another challenge because we are rewriting it in standard form. So we start out with 2x minus 3x equals 8. Again, we've done this. So to get our constant term over and so that we can equal 0, we have our 2x squared minus 3x minus 8 equals 0. That's where they got this here. Now that we have it that way, we can go ahead and we can identify our a, b's, and c's. There's our a term, our b term, our c term. Let's get our b term in there. And now I can apply that to my quadratic formula. So x equals my b term, negative 3, I want a negative b, plus or minus the square root, and I'm going to do b squared, that's a negative 3 squared, minus 4, a is 2, and c is negative 8. That's all going to be over 2 times my a term, which is 2. Alright, I'm going to skip a few here. We're going to do this would be a negative 3 would be 3. And then when we go ahead and we simplify this, I'm going to have 9. And then negative 4 times 2 would be negative 8. And then times another negative 8 would be a positive 64. Again, we have that all over 4 because we're 2 times the 2. Go ahead, and this is going to be that, I guess I could put it there. I have nothing. We have 3 plus or minus, and then our 9 plus 64 would be the square root of 73, and that actually is its simplest form, and that's going to be over 4. Now this one, we're going to have to use our calculator and plug that in so we can get some approximations. So when we're doing the positive, x is going to turn out to be, get rid of my equal, approximately 2.89, I think, yep. And when we're doing the negative value, the negative square root value, then you're up. So again, let's make those approximate. X is going to be approximately a negative 1.39. All right, so moving along again. We'll go back, we took it and we put it into the ax squared plus bx plus c equals 0. We put it into that form, because then we can identify our a, b's, and c's by finding our a, b, and c values. We can put them into the quadratic formula. So, example 3, we've already mentioned, I've mentioned it a couple times, is how we're going to find our x-intercepts of a graph. And we're doing that a slightly different way in lesson 9.4. I think you can see the relationship by putting the two of them together. So, it says find the x-intercept of the graph of y equals negative x squared minus 2x plus 5. So, first of all, you need to use your logic, and the x-intercepts are always going to occur when y equals 0. So that's the first part that we need to do. So I'm going to go ahead and I'm going to substitute the calibration homework 0 in for my y, and 0 is going to equal negative x squared minus 2x plus 5. I substituted 0 in for y because I want to find what the x-intercept will be, and the x-intercept is when I do not have a y value, so y is 0. Now I can go ahead, and it is written in the form I need it to be written in. It's kind of in the reverse order, but I can identify my a value, my b value, and my c value. Now we can put that into our quadratic formula. And so when I do that, I'm going to put that x equals, sorry, hopefully I don't have to pause. It's off again with calibration. I'm going to go over to the computer a minute and see if I can get it before I have to pause. I'm going to go ahead and just recalibrate and not pause the recording. So you're going to see me do the little recalibration real quick so we don't have to start over again. You might not be able to see it because I have it recording off of the screen here. And let's see, maybe we'll take it to the edit room and try to get some of this out of here. All right, so I've recalibrated. We've gone back. We went ahead and we substituted y for 0 because we were looking for the x-intercept. Now we're going to put our formula into the quadratic, or our terms a, b, and c into the quadratic formula. And of course, we're going to run into power here too. So hopefully I can get this last example done. We're going to go with x equals, and it's going to be, let's plug in our values here, a negative 2 plus or minus the square root. I'm using my quadratic formula, negative 2 squared because it's b squared, and then minus 4ac. My a is going to be a negative 1, and 5 negative 1 there, and my c is 5. That is all going to be over 2. When I do that then, I'm going to simplify here, and again it's off a little. X is going to equal 2, negative 2 is 2, so I'm going to do 2 plus or minus, and it's going to be the square root of 4 plus 20. Cheated a little bit there, and that's all going to be over, oops, I lost my negative 2 in that one, negative 2. Okay, so this is x. So now I'm going to get that x is equal to 2 plus or minus square root of 24 over 2. Again, we can't simplify that, so I'm going to get some approximations here. And if it is a positive value in there, it's going to be a negative 3.45. And my other value would be, if I use the negative square root, it would be 1.45. Okay, hopefully we'll make it here with our battery. I'm going to copy that real quick, put that on the next page. Oh, there, I already had put it there in typing. So here's what we figured out on the other page. So we know that the x-intercepts of this graph are going to be at these spots,
And when we first looked at our equation, y equals negative x squared minus 2x plus 5, then we could use our formula, negative b over 2a, to figure out what we have as our vertex, and we could go ahead and sketch our hyperbola.